Okay, so section 1, just on the 4 steps to high-quality observations. If I can move forward. All right, so the first step is just defining clear expectations for teachers. Here's the distribution of actual scores across these 7,500 lessons on one of the instruments, the Danielson Framework for Teaching. And in the version of the Framework for Teaching that we used for this study, there were 8 competencies. One thing to notice is that there were very few people either at the unsatisfactory end or the distinguished end on any of the competencies. That most of the action was between 2 and 3, between basic and proficient on the framework. The second thing is I just wanted to call out for people the specific language on one of those competencies using questioning and discussion techniques. So if all of these instruments, the real challenge is, okay, if somebody's going to walk into a classroom, there are a million potential things you could notice. So I've got a 11-year-old boy who's got ADHD. He would notice lots and lots of things if he walked into a classroom. So it would be important for him to be able to say, here's the set of things to focus on. Here's the set of things to look for. And each of these instruments represent a set of hypotheses about what you ought to tell people to look for when they walk into the classroom. So here were the 8 different competencies to look for, and then here are performance levels on one of them, the using questioning and discussion techniques. And you would get a low score, an unsatisfactory score on that competency if the observer saw you ask a series of yes-no questions, and if the teacher did all the mediating of the questions, so if all the prompts came from and back to the teacher, if just a few students in the classroom were involved in the questions. Now, you'd get a high score, an advanced score on this competency if the questions asked students to explain their understanding, to explain how they came up with a particular answer. If the students started to initiate some of the questions, and better yet, if the students started to ask each other questions, and if most of the students in the class were involved in the questions. So that would get you a high score, an advanced score. Now, 2 things to notice about that. One is that necessarily involves judgment. This is not a checklist. You can train people, but trained people will still have somewhat different judgments. It's unavoidable. The only way to avoid it would be to focus on trivial things like, did class start on time? Did class end on time? Was the teacher wearing a tie? Those kinds of things don't require judgment. You could get 100% reliability on, but probably don't matter that much. The things that matter for teaching are the things that will require judgment. That's the first thing to notice, and you'll see in a second that's reflected in some of our results. The second thing to notice about this is that it will depend on the lesson. So I'm teaching this semester, and I guarantee you the first 3 or 4 days of class, I will not get out of unsatisfactory on this. Because the type of material I'll be teaching those first 3 or 4 days of class is methodological, it's I'm just trying to establish a common vocabulary, and I'm going to go fast and hard, and my students will feel like they're drinking from a fire hose. But just in the way I've done that in the past, that is the best way to teach that initial material. But later in the semester, hopefully, if I've gotten people using the same language, we will have much more meaningful discussion. So later in the semester, hopefully, I'll be mostly proficient, maybe on a good day advanced. So the second thing to notice is this is going to vary from lesson to lesson, and we see evidence of that too. So the second thing to focus on is just ensuring accuracy of observers. The way we handled that in the project was that after people received, I think the average was 27 to 35 hours worth of training on the instruments. It varied by instrument. We showed people videos that had been pre-scored by people who were expert on the particular instrument. And only if the raters could score those videos with a minimum number of discrepancies were they allowed to score in our study. Now, we're trying to make it easy for school systems to do something very similar. So this summer, we're going to be will be available to some of our closest partners, something we're calling the Rater certification tool, where we'll have videos from the Measures of Effective Teaching study, and there'll be software attached so that they're not going to come pre-scored from us. You would have to have your experts pre-score them. Ideally, it'd be great if you could have a lot of your teachers do the pre-scoring. And then only if the raters, once they've received training, if they can achieve some minimum level of accuracy, would they be allowed to proceed to go do observations. So we're going to be doing that. But we know that there are a number of other providers that are starting to offer that kind of service too. And I think it'll be important to have some process for ensuring accuracy before people start to score. A third step is for just monitoring reliability. Now, at the end of training, and even after people were certified, we didn't assume that they were going to be able to score well. That would have been silly to assume that, because you don't know, and that would be particularly true in a real school system, because once people have walked out of the training, they're walking in, especially if they're observing in classrooms of people they know and either like or dislike. Bias can go in either direction. You could have people who could pass the accuracy and be certified but still not be able to score reliably. So the only way to tell is to do, what we did there was we took a random sample of the videos and we had them scored twice. And we could compare the different scores to tell us something about the amount of reliability. And we had the same teacher, because they taught more than one lesson, we could see how scores varied from lesson to lesson. We could actually even see how scores varied from section to section, because the teachers in the study, if they taught 2 sections of the same course, had video from both sections. So we could see how did scores vary depending on the group of students the teacher was standing in front of. And what we learned in the process was that if we just took one rater score based on one lesson And these numbers are for the framework for teaching instrument that we used, but it's similar for the other 4 instruments that we tested. Only about a third, 37% of the variance in the scores from the one observation represented consistent aspects of teachers' practice. The rest was other things. The rest was rater judgment. It was also, importantly, lesson-to-lesson variance. So it wasn't just about rater judgment, it was that teacher would have been different if you showed up on a different day because the material was going to be different. So only about a third of the variance, if you just focus on one score, was due to consistent aspects of practice. Now, there are 2 things you can do if you see reliability numbers that are low like that. So 37% is not good, at least for making high-stakes decisions. There are 2 things you could do. One, you could go back and dumb down the instrument. Say, well, let's focus on the things where there'll be 100% reliability. Let's focus on the things like, did class start on time, or was the person wearing a tie? But a second thing you could do, I think that would be a mistake, by the way, because you'd be focusing on the stuff that matters less. The second thing you could do is say, well, why don't we take a few different, let's observe more than one lesson, and maybe let's get more than one person involved in doing the observations, and let's average them, and then ask how much of the variation in that average represents consistent aspects of a teacher's practice. Now, when we did that, we found that by the time we observed 4 different lessons, each by a different rater, it was then that we got to the point where more than 2/3 of the variance represented consistent aspects of teachers' practice. Now, I just felt like a change in the energy level in this room, because I could imagine people were saying, wait a minute, we're trying to do this. I'm not saying that it's got to be, you're going to have to do 4 observations and use a different rater each time. Because there were things that were unique about our study. Our folks are watching digital video. They're not physically present in the classroom. That probably lowered the reliability. Our folks didn't know anything about the context in the schools. They just saw a video. That also probably lowered reliability. But there were other things that probably increased our reliability, and that was that people had no personal relationship with the people they're observing. So it's hard to tell, it's impossible for us to say how many observations you're going to have to do to achieve reasonable levels of reliability, but we can say that it's important to know what kind of reliability you're achieving, and so you could do something very similar to what we did for determining reliability. You could draw a representative sample of teachers. You could do it as a random sample, or you could do it some other way, as long as it's a representative group of teachers in your district. Doesn't have to be every teacher in the district, although some districts are already deciding to use impartial observers for all. Say you just pulled 100 teachers at random from your district. You sent out impartial observers to go out and do another observation, and then compare the score from that additional observation with the official scores that you've got, and we actually show in the research report that's available. We've got some copies in the back. It's available on our website. We even give you the calculation that you would have to do with those numbers for calculating reliability. And that'll give you a sense for what kind of reliability you're achieving in practice. Again, because it's different from just being able to certify that people can use the instrument, which is important too. But you want to know in practice what kind of reliability are you having. And even just 100 people would give you an estimate of what kind of reliability you're achieving at the system overall. Now, it wouldn't go, that's not enough to tell you school by school what kind of reliability you have, but it'll tell you something about how the system overall is functioning. Now, next, it's important to verify alignment with outcomes. So the whole point in doing this, let's remember, is to help teachers help students learn more. So if the folks who are getting higher scores on the observation are not necessarily getting larger student achievement gains, at least on average, then the classroom observation is not going to be very useful to achieve that goal, right? So it's important to at least check whether there is some alignment between the classroom observation and the other outcomes. Now, what I'm plotting here, I realize it may be hard for some people to read. On the x-axis is the percentile score on each of these observation instruments. So FFT is Framework for Teaching. CLASS is Bob Pianta's CLASS rubric. MQI is the Mathematical Quality of Instruction. UTOP is the UTeach Teacher Observation Protocol. And Plato, in the bottom two graphs, is the Protocol for Language Arts Teacher Observation that Pam Grossman at Stanford developed. So each of those instruments has a different scale. Some are 4-point scales, some are 7-point scales. So we put them all in percentile units to make it easier to see. So that's along the x-axis. And on the y-axis is value added, converted into months of learning units. So 3 things to notice from those 4 graphs. 1, all the slopes are up. That's a good thing, right? It'd be bad if it were flat, or even worse if it were down. And all of them are statistically significant and positive. So on all of the instruments that we looked at, folks who had higher scores on the instruments were seeing higher value added on all of the different outcomes we looked at. Value added on the state test as well as value added on the supplemental assessment. So on the left-hand side are the state tests, in the top state math and the bottom state ELA. And on the right-hand side, on the top is the balanced assessment in math, and on the right at the bottom is Stanford 9 open-ended. So the first thing to notice is the slopes are up. The second thing to notice is not a dramatic difference between them. I'm sure in some of them there were differences, but mostly when I looked at that, I saw mostly similarity rather than differences. So each of the instruments had about the same relationship to these outcomes as the others. The third thing to notice, and this was sort of a surprise, well, partially it wasn't a surprise, was that all of these slopes are flatter on the state ELA tests. Now, this is a very common finding. If you go to the What Works Clearinghouse, if you could find any intervention that's had an impact, 8 times out of 10 it's had an impact in math and not ELA. This is a finding that people have been seeing over time. I'm even used to seeing it in the teacher data. There's less heterogeneity in student achievement gains in different teachers' classrooms in ELA than in math, and less payoff to experience typically in ELA than in math. So I was used to thinking that this was just about literacy, and I think a lot of people think that, oh, literacy is something you learn at home, it's not something you learn at school. Math you only learn at school. I think that's wrong, actually. Or I'm beginning to think that's wrong, because on the right, on the bottom, you see the the Stanford 9 open-ended test, and the relationships we saw there between observations and student achievement gains were much like we saw in math. Now, what's different about the Stanford 9 open-ended is it requires kids to write short answer questions. And one possibility, this is a hypothesis, to explain this, it's not a hypothesis we've been able to test yet, but one hypothesis that would be consistent with that is that, well, gosh, outside of the first 3 years of schooling, teachers aren't mostly teaching reading comprehension anymore. They're teaching writing, starting to teach writing. They're teaching literature, forms of literature. So it may just be that the state ELA tests, which almost uniformly, not completely, but are primarily multiple choice questions following reading comprehension passages that kids are expected to read and understand. It may be that those assessments are less sensitive to teaching effects than assessments that involve more writing and other. And so it could be that as these new Common Core assessments come online, those will be, like the open-ended version of the Stanford 9 we're seeing, more sensitive and show to teacher effects than the state ELA tests we have now.